And a pleasant good morning. Day 3 here at InterGeo 2023 in Berlin. We've definitely walked all of the 5, incredible, right? 5 conference halls. And yeah, let's see what day 3 has to offer. Igor!
Hey Rami, good to see you here at InterGeo. Yeah, come, I'll show you what new products we have.
All right.
We started building this Genesis receivers about 7 years ago with the idea that we can make this really accurate RTK GPS receivers accessible to everyone. So if a traditional receiver is maybe 10 times more expensive than ours, we found a way how to make it under $3,000 without sacrificing performance. And this has been really the key in making AMOLED so popular in many industries. So here, mainly at this show, we are showcasing our RichRS3. This is our latest receiver with tilt compensation, and we're going to talk about this one a bit more later. We also have the RichRX. This is a very easy to use external GPS for your phone, and we are seeing this adopted more and more in construction and utilities. And we have our RichRS2 Plus over here, which I think many of your viewers know really well from drone mapping projects, from ground control points, and we have a lot of surveyors using this in the field every day. But this model is really what this is all about here. So what's the main difference, right? So these are both survey-grade RTK GNSS receivers. They can be a base, they can be a rover, they have built-in radios, but this one has tilt compensation. And I know, Rami, you talked a lot on your channel about tilt compensation, but just a quick overview on what this allows you to do. So with tilt compensation, you can make measurements without holding your rod plumb, and this speeds up the data collection and stakeout so much. And I think mainly the stakeouts are so much quicker now with tilt compensation. But actually software is the biggest part of our company, and this is what our customers are interacting with every day. And we have a few things here, and I know you showed AMOLED Flow on your channel. And the beauty of that is we are pretty much the only company that has survey functions on iPhone and iPad. And we are also pioneering instant sync with the Flow 360 cloud service. And what this does is that basically this works like any modern digital platform like Google Docs, where any data that you collect in the field is immediately available in the office, so just like within milliseconds. And then if you import something in the office or update the data for the field guide, it's immediately available in the field. And this is also easy to use and powerful, so I really recommend you give that a go. It's really popular for the drone pilots is AMOLED Studio. AMOLED Studio is a free-for-all application, so if you are flying any kind of RTK or PPK drone and maybe you don't even have an AMOLED base station, you have it from some other brand, you can still use AMOLED Studio to process the log files and do the geotagging before you sort of take those pictures into photogrammetry software. And again, this is completely free, so anyone is really welcome to use it. And this is going to be the last bit of software that we are building here is the AMOLED Caster, which is also a free tool where you can easily connect your base and rover over the internet. And again, it's brand agnostic, so just feel free to give it a go.
All right, I'm at the Faro booth, and I'm here with Toby. Toby, tell us a little bit more about Faro and what kind of services and products you guys offer.
Yeah, hello. Welcome to the Faro booth here out of Berlin. We presenting here our whole portfolio of laser scanners. Yeah, so maybe starting with the Faro Focus Premium Laser Scanner. It's a terrestrial laser scanner standing on a tripod, coming with 3 different ranges. We are talking about 70 meters, 150 meters, and 350 meters. So you can do a scan with color, without color, on a really high quality, on a tripod, coming with different resolutions and with a really good quality in terms of point dense and range. So introducing the newest system from Faro. It's the Faro Orbis. It's a handheld mapper, so a SLAM technology, coming here with a monopod. So you have the LiDAR hook on it, you have a camera, and you have the Faro Stream app running here on the system. So if you want to do scanning, you just can click in the app, create a new sheet, for example, and we are ready to go just by playing, press playing, and then we should start. Now the system is starting. We have to stand still for about 15 seconds now, and after that we are ready to go. Okay, so now the LiDAR is moving and we can start walking. So the difference between the terrestrial world and the SLAM world is standing still or walking around to capture data. As we are walking around, you see how the map is popping up in the Ferrous tree map, and you can see here a top-down view of the scene and also the trajectory. So we can go at a normal walking speed with the device and capture everything around us. If there is something we need more detail, we have here something special built into the system. We can now capture a flash scan. So a flash scan means you have to stand still at least for 15 seconds, and now we're capturing a statical scan with a SLAM scanner. After the 15 seconds, we are ready to go and moving around again. You see how the map is increasing on the phone, and if we need to do another flash scan, we call it. So again, trigger a flash scan, standing still for another 15 seconds to capture more detail on a specific area with a higher point dense and a better accuracy with the SLAM device. Okay, so the color is always captured here with the 360 camera. We are doing 1 picture per second. If we are done with the acquisition, we just stop everything and all is done. To process the data, we have 2 different options. Upload the data directly to our Faro cloud solution, Faro XG. There we can directly process the data, automatically filter the data, and we are ready to share and collaborate with the data with everybody. The second option we provide to the customer, we have an offline solution. So the offline solution means we transfer the data on the data logger directly to the computer, to your home computer, and then we start processing the data offline, so the data security is always there. What you see here is Faro Connect. Faro Connect is here to process the data on your computer. Like I already mentioned, you can do this online in Sphere, or you can do this on your own offline in the Connect version. Here you see an already processed point cloud. If you're looking here, it's a nice colored point dense point cloud. If you're looking here at the data, it's loading here, and this is a mixture between a SLAM and a terrestrial world. So here you see the flash scan. You see there's much more dense in the data, and the flash scans are already registered in the scene through the SLAM algorithm. If you want to see, for example, the panoramic picture coming with the system, so now we are just navigating here in the panoramic picture. You see everything around, it's a bubble view. So now just looking here on a simple photo. So we have both, we have color point cloud and we have the bubble views coming here with the new Faro Orbis.
Fantastic, thank you. For anyone that's wondering, here's what a CORS antenna looks like at a CORS station, right there. The big white hat. That's the antenna used to send base corrections to your network RTK. And in case you don't believe me, here's another one. These guys are manufacturers, I believe. Maybe you want to set one up on your house. I don't know. So I'm here with Dr. Nick, the Director of Geospatial Solutions at Bad Elf. And tell me a little bit more about this GNSS receiver and what Bad Elf is all about.
Yeah, Rami, appreciate it, and appreciate everything you're doing in the survey, mapping, geospatial world. Love following all your videos, so absolutely appreciate it. So this is our new Bad Elf Flex Mini. We came out with it just a few months ago. We released it and debuted it at the Esri Users Conference in San Diego in 2023. So this little device here, this is really designed for that near survey grade GIS applications. It comes in 2 formats. The standard format retails at about $500 USD in dollars, and that's going to be about a meter and a half. It's a replacement of some of our older hockey puck units, or the Tamagotchi units, if you remember those. And then what's kind of more exciting to me anyways is the higher accuracy extreme version. So quad constellation, multi-frequency, tilt sensing, but we have the ability to connect into an RTK network. And at that point, you're getting sub-foot easily, and we've seen as good as about 10 centimeters. So in the space of Bluetoothing with your phone or tablet, perhaps you're using an app like ESRI or AppGlows or something else. It's a great device to get you off and running, collecting, really good data. Yeah, so I can show you real quick. This is kind of the box here. We tried to design it in a way that it looked like sort of an Apple.
I was going to say, it looks like an Apple product.
Yeah, Steve Jobs. Okay, all right. You've impacted us. So they open it up.
It's an experience.
Yeah, you pick it up, and then literally you'll QR code this, and then there's a QR code sticker on here, and that will send you right to like downloading our app, getting all started. And then if you're excited and you want to learn a little bit more, we have this fun QR code that may or may not take you to a YouTube video of Rick Roll from the 1990s. I don't know. We like to have a little bit of fun. But one of the neat things is we've created this really lightweight, very simple connector that actually will work with a phone or tablet. It's an SP Connect piece, so if you're familiar with GoPro products, basically you snap it onto your phone, and so the average GIS user walking around collecting data, maybe you're an architect, biologist, you've got your entire solution here attached to your phone, very, very lightweight. The battery's got 24 hours plus on it, and so you're not draining any of the battery from your phone to do these things, so it's pretty exciting. You can also attach this unit with a 1/4-20 mount, again, GoPro standards. Right. It has to have a magnet on the bottom, so if you want to attach it, say, to a side-by-side or on top of a vehicle.
Oh, yeah.
So, some other type of mobile solutions, but yeah, it's IP68, so waterproof, dustproof. That's all they wrote.
Fantastic. I love it.
You can check us out, bad-elf.com, so bad-elf.com. You can check us out there. We also have if you're a GIS person, you go to hub sites and you like story maps. If you type in Bad Elf, search for us, you'll find a neat hub site where we show our geospatial enablement. I should mention as well, we don't just sell hardware. So we actually are involved with implementation, training, deployments, and so we'll actually go into state and local governments, private organizations, and help train them up, get their GIS systems, geospatial systems set up. If they want to do drones or LiDAR, help make those connections. And so really trying to segue away from just a hardware manufacturer and really being an active geospatial just kind of support company.
You're building an entire ecosystem.
That was much more articulate.
Oh yeah.
It's been a long 3 days for anybody who's never been at Intergeo.
Oh yeah, I don't think I've ever been this drained at a conference, but it only just shows us how much there is here. It's just amazing. So great. Well, thank you, Nick. Appreciate it.
Rami, appreciate it. Like I said, if you're watching this video, definitely check him out on all his other videos. He's great. His work is great. You can also find me on LinkedIn, other social media sites, The Bad Elf. So thanks, guys.
So I just discovered a new YouTube channel.
Yes, it's AppGlows.
I'm going to try to explain this, and you're going to help me. There's the other team member right there. They make videos about surveying, but in like a castle. So tell us more about that.
Yeah, well, we have a video actually. Well, in the beginning, as you can see, that the software is the AppGlows Survey Wizard. So if you have a wizard, we actually also need some housing to go with that. And that's why we found the castle, right? So, and meeting up with Bad Elf, it means now an elf has come inside the castle, and that's why we have the castle. True. It's a true story. The castle exists from, let's say, 800 after Christ, and it went through a lot. And actually, in the last 7 years, it had to go through us.
Now you're a wizard.
Yes, now it's the wizard.
Actually, I'm not the wizard. I should be like the knight, because he is like the wizard, and I do the talking. That's it.
He's the brains wizard, I'd say.
He has the brains. I cannot do anything. I only can talk, and that's.
I have the brains, but you can't say he has the beauty.
Well, you need to be able to talk to sell, and then you need to have wizard brains to develop. So
synergy.
There you go.
That's
Very good. Very good.
Like yin and yang.
YouTube.com/AppGlows.
AppGlows.
Very good. Go check these guys out. Very hilarious content. I was watching some of it yesterday, so very unique. I would have never imagined someone would make it.
Did you see the Lego one?
The Lego one? No, I didn't.
We built a GNS receiver from Lego.
Oh, no
with
kidding.
A drop test, but we also built the biggest antenna receiver you can find, just to check out if the surveying will go on inside a forest, and maybe the bigger antenna it was huge. You have to watch that one.
All right, this has been a very popular booth. This is Novice, and they have what I like to call the body slam. I'm sure there's a more official name for it, but we're going to talk to Carl, the senior account executive, and he's going to tell us a little bit more about their product. Carl, nice to meet you.
Yeah, good to meet you.
Tell me more about, okay, I want to know the actual name of this device.
It's not the body slam, but this is the Navis VLX3. It's the third generation of our VLX family. VLX has been around since 2020, and yeah, some kind of fundamental changes have happened over the last 3 years. So the system itself is a SLAM-based mobile mapping system. We're using dual 32-layer LiDAR sensors, each of which are capturing about 1.28 million points per second. Our previous generation, on the other hand, was capturing around 600,000 points per second. It also has a range of around 50 meters. The LiDAR specs say 300 meters. We don't use that because you just aren't getting good data with any system if you're more than 50 meters away from it. Yeah, in terms of the sensors, we've got 4 20 megapixel cameras up on the top. We're a cloud first company, so all of our data is processed on the cloud, and that usually means that an hour of mapping, which is sometimes up to 10,000 square meters, can be processed overnight. So pretty much if we go out and map this hole today, by tomorrow we've got a deliverable. Fired up the scanner, that takes around 30 seconds to kind of put together and get going. Very, very easy user interface. So you can see here we've got our battery level. If I take one of the batteries out, it'll tell us that it's missing. So they are hot swappable. You can see that I'm actually missing a solid state drive right now, which I'm going to grab. Just 1 second.
10 seconds later.
There it is. There we go. So yeah, we got a 1 terabyte solid state drive. That's just gonna jump into the side of the scanner. Doesn't matter which way you put it in. Okay, and now we are looking at the user interface. Very, very easy to kind of assess your data, that the sites that you've captured on the device. But for now, we're going to start a new scan. So I'm just going to give it a name. So it's about to prompt me just to turn 90 degrees. And what that's going to do is it's going to initialize the cameras. So the 4 cameras that are up top. So I've turned. And now you can see we're mapping. So what you're seeing on the screen is the geometry that we've captured. Obviously, we've just started this scan, so we haven't captured much yet. But you'll also see a little icon of the VLX system. And you'll also see if I'm moving around, it will be tilting on the display. The white kind of squiggly line that you see, that is our trajectory. So that's where I've walked. I've got a thumb trigger that is just above the handle. And if I hit that, we will capture the panoramic imagery. We can also automate that workflow. So in settings, we can set an auto trigger distance. So right now it's set on 1 meter. If I hit auto, as I move forward, it's going to signal a tone, which is telling me to stop. As I've stopped, it's then going to trigger that sensor, and then you can carry on walking. So let me just move through the space. Okay, now we've captured the first 2 panos. In an environment like this, I would usually take a pano every 3 or 4 meters. But obviously, if you have a more detailed environment or just a busier environment, you can choose to capture a pano every kind of half a meter if you want. You'll see also that squiggly line, that's my trajectory. So that's exactly where I've walked. In terms of the colors that you're seeing, the bright blue data, that means we've got good, rich, dense data. And then obviously the white lines are geometry from walls and geometric features in the environment. What you'll see where it's kind of this faded blue or kind of black areas, those are just voids in our data. So that's a good sign that you need to move into that space. So if I did a lap around this booth, we're going to fill up that space really quickly. I know my colleague scanned the entire hall yesterday. I think it took him around 25 minutes, and it's quite a detailed scan. And yeah, captured everything from the HVAC systems to the steel structure at the top of the venue, and then obviously all of the booths. Once we're done mapping, I'm just going to hit pause and save. And that's a scan done. If I hit finish, it's already saved. The next step in the workflow, I'm just going to take the solid state drive out. As long as I have an internet connection, I'm going to upload that data and start the automated processing. A scan like this of 5 minutes will be done within an hour. If you've done a longer scan of 1 hour, for instance, that's going to take around 10 hours of processing on the cloud. During that processing, we're going to colorize the data. It's obviously going to go through multiple iterations of SLAM to try and get the best results that it can. And in an environment like this where it's really feature rich, I would expect an absolute accuracy probably within a centimeter. fairly accurate device, really quick, really easy to use. And I think the real champion is just the software in the system. Very powerful SLAM algorithm, very robust, and then also just the processing. Having the cloud work for you while you're sleeping, I think is a game changer. Certainly for me, I'm a surveyor, came from years of laser scanning and just registering terrestrial scans together. So yeah, I really love the system.
Great, thank you.
Cool.
And a bittersweet moment now. It's time to say goodbye to InterGeo 2023, and I look forward to InterGeo 2024. Thanks everybody for watching, and until next time.